to the microcontroller here, and it's injecting traffic into the transmitter chip. So you want to switch displays.
All right, should we try to use the manual control first? I don't know what keys do what. But all right, there we go. Hi. Thanks a lot, you guys, for coming to my BlackHat talk. Welcome to my presentation.
Okay, so that was him using the original device, and now this device I've rigged a bunch of the different switches to send different types of commands. Some of the switches go forward and back. There are switches that are set up that while you hold on to it, it'll just keep on sending forwards, and then I have another switch that you press it once, and it'll start sending, you press it again, and it'll stop. So I set my automatic command to just send tons of page downs, and took this flip book and made it into separate slides into the presentation. So you have something to look at while it scrolls through and injects into the receiver. It's a pretty long flip book, actually. Can you switch back? So as a summary, the first thing you want to do is look at the FCC ID, look up all the information you can get from their website. You want to tap into data path, reverse the protocol, hook up your custom chips, and start sniffing and injecting. And all that's going on here is we have client-enforced security. We're trusting the transmitter to send the appropriate serial number, and that's the only thing that's stopping it. One more thing I wanted to mention is once you start programming these chips, you can start making your own tools. You can. One thing I've been working on is making a custom sniffer chip. So when it sees that kind of clock sync, it'll figure out what type of spacing it is, and it'll start outputting the bits for me as a normal bit pattern, and then that'll be hooked up over USB, and I can basically, like a poor man's logic analyzer that auto finds the times and the time periods. So that's it. Is there any questions? Yeah, that's the first thing that I wanted to try. Obviously, if this supports a keyboard interface, that's what I want. You want to send keyboard commands. Unfortunately, it didn't work. I tried the whole key space, and no other commands went across. The actual amount of data that's going across the wire is very small, primarily because since it costs a lot of battery to send data, they're going to try to limit the amount of data, so they're not going to cover the whole key code space. So yeah, unfortunately, I wasn't able to do that. As far as the keyboards go, I've been able to receive data that is coming across, but I haven't been able to reverse the encoding that it's using yet. So along those lines, what I've done is kind of build like a proxy system, so I can get some data, modify it, and send it across and see what happens to try to reverse it. So fault inject some data and see if what happens on the other end, how it's interpreted. Any other questions?
Have you gotten to play at all with any of the infrared wireless microphones?
No, I haven't.
Wondering, a lot of times a simple replay is all you need. Maybe wanting to replay unlock or something like that. But I haven't seen anyone present a sort of generalized record and replay that they all seem to go through the stages of the protocol and then retransmit, replay the instructions folks aren't trying to do a more generalized record and replay? Is that technically hard?
I don't see why it would be, but that's where it's really like behooves you to have it hooked up to a computer so you can sniff, process data, and send the same data back out. Some of these more advanced logic analyzers are able to do data generation, which is what I'm working on myself to be able. I just want one channel data generate. Something else to look at on the keyboards is in that case you really want to look at the traffic between the EEPROM and the CPU, because they actually do proper pairing. There's if it gets unpaired, there's a button at the bottom where you sync up the devices. So that type of data would be important too. So then you can see, oh, they're doing a read from the chip and they're doing a write, and we know what value and what address, and then try to extract that from the data coming across. So that's another some more known clear text. That one was 389, and it's 34 channel, and I believe it's 200 megahertz bandwidth. I have it right here. I can hold it up. So it comes with this. It has 34 connectors, and then you have to hook up something else to these pins. You can hook up clips like this, or it can go directly into some kind of header on your board. So a lot of times when you're debugging your board, you're going to have some type of header, so you just hook right in. Any other questions? Well, thanks for coming, and if you have other questions, just find me later. Thank you.